Thanks, Kale. So let's talk a bit about observability for AI, or in particular, observability for agentic systems. We're finding that this is a pretty common gap amongst folks that are building with AI. My name is Dan Jungst, and in a bit, I'll be joined by my colleague Shashank Pradhan, who will be showing us some next level observability in action. But before that, let's dig into the problem. Observability has been around for a long time. We all know that. But something new has come up that needs to be observed. It changes the game. Can you guess what that is? We hear over and over again from teams that are putting agents into production that agent workflows are opaque and they branch and they retry and they call tools and they hand off to other agents. And we can only see the fragments of that. Can't really see what the agent does as a coherent whole. So when something breaks, it probably isn't the LLM. It could easily be a downstream API, a database, a broken tool call, could be in any of the layers. And these systems are non-deterministic. The workflow never runs the same way twice. So static dashboards and predefined alerts just don't work. You really need an end-to-end view from agent invocation to the LLM call to the application code and any errors along the way. So every organization is adding AI agents today, right? They're adding them to their new applications and to their existing applications. Say you want to add a customer support agent, right? Simple. See, it sounds easy, but it's not just one agent. It's probably several agents working together, each making their own LLM calls and tool calls to get the job done. So already the surface area is bigger than any one engineer can hold in their head. The real question is, do you know what these agents are doing in production? Do you know how they're interacting over time? Do you know the conversations that the agents are having with your users? For most teams today, the honest answer is no, not really. If you think about it, debugging in this world is like investigating a plane crash by reading the fuel gauge. You know why the engine stopped, but you don't know what led up to it. You have no flight recorder, no sequence of events, no connection between cause and effect. And here's why nothing on the market today fixes that problem. Your dedicated LLM, eval, and observability tools, such as Langsmith and Arise, they understand model behavior, but they never see the database or the API or the downstream service. So traditional old school APM monitoring tools like Datadog and Dynatrace, they see HTTP requests and responses. But full agent conversations, handoffs, tool calls really don't even exist in their model. Engineers today are really having to stitch traces together by hand. They're tab hopping across multiple tools or even into Slack threads. And while the incident is still burning, causing problems. Nobody's really connecting all the layers today. That's the connection that we are making today. Full observability for AI for the agentic era. We're excited to announce some new capabilities within Honeycomb that help solve these challenges and are built on our foundational observability. First, Agent Timeline. Agent Timeline gives you an agent conversation level view. You can see every agent call, every LLM handoff, every tool call, and every trace that an agent makes, all bound into a single conversation. We're also bringing deeper LLM insights to give you the per request telemetry that you need around AI, things like prompts, tokens, models, latency, and quality scores, all as first-class span attributes. And they both sit on the high cardinality event-based foundation that Honeycomb has had for a decade, and which is a perfect fit for this new kind of telemetry that agentic systems produce. Agent Timeline is really the first observability experience purpose-built for debugging AI agent workflows in production. As we saw earlier, agents carry on conversations. The Agent Timeline renders that entire long-running agentic conversation as a visual sequence. We're flipping the script today. Normal tools today force you to start at the span and work up. We start at the conversation and drill down into what matters. Agent Timeline gives you the complete conversation view. It lets you understand your agent behavior. It helps you debug faster, and it lets you trace everything. Agent Timeline is the distributed tracing for the agentic era. So here's what engineers actually get. They get AI spans and systems in one trace waterfall, so all in one, all together. They get failures as first-class citizens, execution and latency today, and additional agent-specific failures coming soon. And they get a real-time information about agent and LLM help. We do this using telemetry conforming to the OTel GenAI semantic conventions, so it falls right in. Let's see Agent Timeline in action. I'm going to turn the mic over to my friend and colleague Shashank from our product team. Shashank, what do you have for us?
Thanks, Dan. Today, we're excited to address something that's quickly becoming essential for our customers: understanding your AI agent's behavior in production. And to do that, we've created the agent timeline, which shows you an end-to-end view of your single or multi-agent conversation all in one place, stitched together with a simple conversation ID where we're following standard OTel GenAI semantic conventions. So with that, let's dive right into the demo. The agent timeline has multiple ingress points across Honeycomb. You can access it via the trace waterfall or the query builder view as well. But today, I'll role play as an engineer at Starfield Technologies. And we recently just launched a new AI powered support agent. And our support team just came back to us saying a customer had an issue, and they sent us a conversation ID, and that's it. And so we want to understand what the context was and how to fix the failures and what they are. So I just paste in the conversation ID here, and that loads the agent timeline immediately. Right up top, you can see a quick summary of the conversation: the time it took, the number of LM calls, the number of failures, more importantly, and the total tokens consumed. Underneath, you see the actual agent timeline. Here, we've got two different swim lanes showcasing two different agents: the supervisor agent and the order status agent. And you can actually expand these swim lanes further to see all of the operations and actions that the agent took across the span of this conversation, across these categories: agent invocations, LLM operations, tool calls, and others. So to get context, I'm just going to dive right into one of the spans. Let's get right into this invoke agent supervisor span. And that opens this GenAI panel on the right. And the GenAI panel is really powerful because it provides really complementary data to the timeline itself. You can see what model this agent spoke to. You can see the evals metrics that we ingested across bias, relevance, and hallucination. And more importantly, to understand context, we can actually see the messages that the user and agent exchanged. So it seems like the user came in asking about the status of their most recent order, and the assistant gave a relatively straightforward response. And so that's great because now we understand the context in terms of what the goal was that the customer wanted to accomplish with this conversation. But we're here to solve an issue, right? So let's dig right in. We're going to toggle the show failures only, which immediately pinpoints the failures that exist in this conversation. And you can actually expand on this order status agent. And we can see that there are 16 different failures, all coming from the same tool call. You can see the tool name right here, check shipping, and the exception type and exception messages that the shipping service was unreachable, and there was a connection error. So this gives me and my team a really good starting point with the user context, as well as the failures, to ensure that not only can the tool call be more reliable moving forward, but that future customers don't have the same issue around latency because of failed tool calls in this instance.
This is really cool stuff, Shashank. Literally next level observability. One of my favorite things about agent timeline is how it allows you to combine this agent observability with traditional application observability. Can you show us a little bit about that?
Sure thing. So far, what we've seen on the timeline are largely agent operations, and they're led directly by the GenAI spans that you can see. But we at Honeycomb believe in full stack observability. And in many of your agent workflows, you could also have backend services, databases that are not GenAI related. And so to serve that use case up as well, we added the trace waterfall component at the bottom. And this is correlated directly with the timeline. So if I click on a span here, it loads the respective trace and span at the bottom, where you can actually see the different tool calls in this instance and the responses, again, all in one place. But you can also scroll to see non-Gen AI operations and tools and API calls, etc., all in one place. To be able to troubleshoot this kind of issue that we went over today, typically customers would need a trace ID, digging into agent logs, and taking a long time to really reconstruct the context of this conversation. But we serve this up in a very simple, direct agent timeline view. And today we're really excited to announce that the agent timeline is officially in early access for all of our customers.
Thanks, Shashank. Great stuff. Can't wait to see this in action. Honeycomb is the observability platform for teams and agents. It starts with our foundational OTel native observability platform, and then we layer on agent observability, which is the work we just walked through. And finally, we add agentic intelligence or observability with AI That last piece is where we're going next.